Okay, so the next section that we're going to talk about is the intermediate value theorem. So we're going to talk about the intermediate value theorem. So just thinking about intermediate value, that the phrase just means a value in between two other numbers. So that's kind of the idea behind the intermediate value theorem, is that a continuous function can't skip values. So the idea behind this is that a continuous function can't skip values. One way to think about this is think about if you were driving. So if you're driving your car and you're getting on the interstate, and you go from 0 to 60. So that acceleration and your velocity, that's continuous. You didn't stop the car. At some point you had to have been going 45 miles an hour. At some point you had to have been going 37 miles per hour. Since you accelerated from 0 to 60 and it was continuous, any value in between 0 and 60 you had to attain. So that's what the intermediate value theorem says. So here's the formal statement of the theorem. It says if f of x is continuous on a closed interval from a to b. So that's what we're going to start with, is that you need f of x being continuous on this interval that's closed, meaning I include the two endpoints. And f of a is not equal to f of b. Then, for every m, so value of m between f of a and f of b, there exists some c in the interval from a to b not equaling the two endpoints, such that f of c equals m. So this is the formal statement of the intermediate value theorem, is that if I have a continuous function on a closed interval from a to b, and my two function values at the endpoint are not the same, then for every number between those two y values, there's an x value corresponding to it. Now graphically, what does this mean? Let's say here's my function f of x, and let's say that here's my a and here's my b. I think we can agree that this is continuous on the interval from a to b, so for every x value between these two, this function's continuous. Here's my f of a, here's my f of b. What the intermediate value theorem says is that for any m between these two values, so let's say I choose this one, then there exists some c between a and b that corresponds to it. That's what the intermediate value theorem says, is that for any value I choose between these two y values, I had to have had an x value corresponding to it, because the function is continuous. So that's the intermediate value theorem, and we're going to show how would you actually apply this. But again, the idea behind it is that if I have a continuous function on an interval, and these are the two corresponding y values to the endpoints, then for any y value between these two, there was a corresponding x between a and b. So how do we actually apply this? A lot of times we're going to apply this to determine solutions. So we'll do an example where we're determining a solution. So is there a solution to 5 to the x squared equals 10? So does there exist an x such that this equation is true? Now the question doesn't say find the x such that this is true. It just wants to know, is this true? So is there some x to where this is true? Well, let's let f of x equal 5 to the x squared. We know this is continuous. This is an exponential. This is continuous for all x. What else do we know? So we know it's continuous. We know what f of 1 is. what is f of 1? F of 1 is 5 to the 1 squared, which is 5. We also know what f of 2 is. F of 2 is 5 to the 2 squared, which is 5 to the 4th, which is 625. Right, so we know that on the interval from 1 to 2, f of x is continuous. I also know that f of 1 is 5, f of 2 is 625. So let's write all that down. So on the interval from 1 to 2, f of x is continuous. And f of 1 is 5, f of 2 is 625. Since I have that f of 1 is 5 and f of 2 is 625, any value I pick between 5 and 625, there had to have been a corresponding x value. So, by the intermediate value theorem, which we're going to abbreviate as IVT, there exists some c on the interval from 1 to 2 such that f of c equals 10. And remember, f of c, so this is the same thing as saying 5 to the c squared equals 10. So there was a solution. We found that there was a solution by the intermediate value theorem. Pictorially, what is this saying? So my function looks something like this. Here's 1, here's 2. This value we said was 5. This value we said was 625. We said it was continuous between 1 and 2. And we also know that 10 was between my two y values. So by the intermediate value theorem, there is a c corresponding to 10. So because we were able to find the interval 1 and 2, or 1 to 2, we were able to say, because of the intermediate value theorem, there's a c corresponding to 10. So that's one way you would use the intermediate value theorem. So a solution does exist. Another way you could do or use the intermediate value theorem is to find roots and zeros. So roots and zeros, which are the same thing. So roots and zeros. The way you want to find roots and zeros is to, so you want to find these, you want to choose a and b appropriately so that f of a and f of b have different signs. What I mean by that is that if you find that f of a is positive, you want f of b to be negative. If f of a is negative, you want f of b to be positive. The reason is, if one is negative and one is positive, then 0 is between those two, and therefore there has to be something corresponding to 0. So let's do an example of this. Let's let f of x be negative x to the 7th plus 5x cubed minus 2x squared plus 1. Does f of x have a root? So of course you could look at the graph, but let's say I want to use the intermediate value theorem. And let's maybe think about this for a second. How about plugging in 2 and negative 2? Let's just see what happens. So let's try some values. What is f of 2? So f of 2 is going to be negative 2 to the 7th plus 5 times 2 cubed minus 2 times 4 plus 1, which I believe is negative 95. What about f of negative 2? F of negative 2 is what? Negative times negative 2 to the 7th plus 5, negative 2 cubed minus 2 times negative 2 squared plus 1, which was 81. What I've just done is I've found two x values that give corresponding y values of different signs. Since f of x is continuous, it's a polynomial, it's always continuous, on the interval from negative 2 to 2, and f of negative 2 is 81, f of 2 was negative 95, then there has to be some c value. So there exists c from -2 to 2, such that f of that c was equal to 0. Now there might be more than one, we don't know. But between -2 and 2, there's definitely some x value where I went through the x-axis. So what is this picture looking like? I mean, you don't need the picture, but just so we can understand what's happening here. I have my function. Here was -2, here was 2. I found that f of 2 was -95, and I found that f of -2 was 81. What the intermediate value theorem said is that it might go through the x-axis more than once. I mean, it might do something like this. It doesn't matter. There's at least one place between -2 and 2 where I had to cross the x-axis. So there is a solution. So, in conclusion, f of x does have a root. Again, it might have more than one. We just showed that it has at least one. Because f of -2 was positive, f of 2 was negative. I had to go through the x-axis. So that's how you would use the intermediate value theorem to find roots. The last thing we'll look at is how do you know something exists? So existence. For example, does the cube root of 5 exist? Well, the intermediate value theorem, to use it, you need to have an f of x, and you need the f of x to equal some number. So we need to figure out some function that would correspond to the cube root of 5 existing. So we need a function. We need a function equal to some number. That's the only way we can use the intermediate value theorem. If the cube root of 5 exists, let's say that it's x. Can I think of a function equal to some number from this? I mean, the cube root of 5 is not a very nice number. Let's think of an integer. What happens if I cube both sides? It would be the same as x cubed being 5. So asking the question, does the cube root of 5 exist, is the same question as if f of x equals x cubed, does f of x equal to 5 have a solution? Right, if I can find some x value where x cubed equals 5, then I've found a solution, and that means that the cube root of 5 does exist. So I took this cube root of 5, changed it to be a function equaling some number so that I can use the intermediate value theorem. So now to use the intermediate value theorem, again I'll write here what we're trying to do. We're trying to set x cubed equal to 5, and we said that f of x was x cubed. To use the intermediate value theorem, I need to find an a and a b where f of the first value is less than 5, f of the second value is greater than 5. So let's think. Let's try, how about 1 and 2? Let's try a equals 1, b equals 2. What's f of 1? That would be 1 cubed, which is 1. F of 2 is 2 cubed, which is 8. Does 5 live between 1 and 8? Definitely does. That means that there has to be some c value between 1 and 2 corresponding to 5, because this is continuous. So since f of x is continuous on the interval from 1 to 2, those are the values I chose. And these are definitely not the only values you could have chosen. You could choose anything so that f of the first one is less than 5, f of the second one was greater than 5. So since it's continuous on that interval, and f of 1 equals 1, f of 2 equals 8, then by the intermediate value theorem, there exists some c between 1 and 2, such that f of c equals 5. So since I was able to find an interval where the corresponding y values were 1 and 8, there isn't a c value corresponding to 5. Now pictorially, what is this looking like? We were looking at 1 to 2. So we said that f of 1 was 1, f of 2 was 8. There's my function. The intermediate value theorem says since this is continuous, there's some x value corresponding to y being 5. The question didn't say find the x value, the question just said does it exist. So because we were able to find f of c equaling 5, that means that c cubed equals 5, which means that c is the cube root of 5. So yes, the cube root of 5 does exist. It's between 1 and 2. That's the cube root of 5. So by using the intermediate value theorem, we were able to show that the cube root of 5 exists. So that's how you can use the intermediate value theorem. Again, what you're going to do is find an interval where the y values kind of surround the solution that you want, and then you'll say by the intermediate value theorem there exists a number between the two x values such that you get the y value that you want. So that's the intermediate value theorem.